Okay. So what you need to do is, this is paper 1. So if you're doing this paper 1 question without calculator, your y is equal to sin x. Now what you can do is you can draw a rough sketch of y is equal to sin x. You know the sketch. Yeah. So this is 0, this is 2 pi, this is 1, this is minus 1, correct? This is pi, so this is pi by 2. So if you have to draw a domain of, now this is your final answer. So if you are doing this in the domain from 0 to pi by 2, correct? It will only be this much. Correct? So this is my graph of y is equal to sin x. Now the other graph is y is equal to
sin 2x.
Sin 2x. So period is equal to 2 pi divided by b. Pi. So period is pi, means this whole graph will complete in pi.
Yeah.
So that means this will be like this. Then find the coordinates of the point of intersection. Achha, by the way, it's very important that you draw your graph only in the domain. Don't go beyond the domain. I'll cut your marks. So this is my graph.
Okay. Point of intersection you just
equate them. So what will it be?
So it will be sin x is equal to sin 2x.
Then?
And when you make a sin 2x, you use that identity.
So sin x, that's 2
sin x cos x.
Sin x cos x. Then?
Cancel out sin x.
No, don't cancel out. You lose a solution. Get all terms on one side, factorize.
Okay. Oh, 1 minus 2 cos. Sin x is equal to 0. So x is equal to
or
0.
Cos x is equal to half.
Yeah.
So x is equal to 0 is the only solution in this domain.
Correct. Because cos. Correct.
Other is coming as pi, which is out of domain.
Yeah.
X is equal to cos inverse of half. What is cos inverse of half? Pi by 3?
Yeah,
60 degrees basically. So basically this is your point. This point is pi by 3.
Right.
Find the point of intersection in this domain.
Yeah.
Find the area enclosed by the graphs. So what is the area enclosed by the graph?
So from 0 to pi by 3, outer function minus, higher function minus lower function.
Yeah, pi by 3. So that's your sin
2x minus sin x dx.
What is the integral of sin 2x?
Sin
minus
2x by 2.
Minus cos 2x.
Minus cos 2x divided by 2.
Correct?
Yeah.
Because this will become minus become plus. Pi by 3, 0. Now
cos 2 pi by 3 divided by 2
plus cos pi by 3 minus cos 0 upon 2 plus cos 0. What is cos 2 pi by 3?
Cos 2 pi by 3 is 120 degrees.
Cos 120.
Yeah, so cos 120.
Pi by 3 is 60, so 120.
Yeah.
So that will be minus, same as cos 60.
So
cos 60 is half. Yeah. So minus half basically.
Plus
cos pi by 3 is half.
Yeah.
Cos 60 is half. Correct?
And cos
minus
0 is negative
1,
half.
Negative half plus 1. So that's 1/4 plus half plus half plus 1. So basically 2 1/4.
Yeah.
So that's the area enclosed.
No, so minus 1. So it will be 1/4 plus half minus 1.
Arey, what is half plus half?
1.
1 plus 1?
2.
2 plus 1 4? 2 1 4.
No, not like that. So I'm saying when you open up your brackets.
I did that.
No, but so doesn't that become
Arey,
minus 1? Why would that
this
be
is
plus 1? So the first.
Sorry, my mistake. Yeah. So minus 1. So this and this will cancel out. Correct? So 1/4. Yeah.
Okay.
Then
Then next part.
Next
That was the hard part. So this is the hard part.
This is part B of this. So what will you do in this case? Substitute.
What is wrong with this thing? It's in 12th of Feb.
Must be, I must open this paper earlier.
No.
But how can be 12th of Feb? Must be. So dx by d theta.
So I couldn't differentiate this thing. How do you
What?
differentiate this?
What is the meaning of 4 sine? This is 4 sine theta the whole square. So that's how much? 4 to the 8 sine theta into derivative of sine theta is cos theta.
Oh, like that.
So what is my dx?
8 sin theta cos theta d.
Correct? That's my dx.
Okay.
Right?
Yeah.
Now my denominator, let me simplify my denominator separately, is 4 minus x. 4 minus 4.
So can you just take the root of
4,
the denominator?
1 minus sine square theta. 4.
Cos square theta.
Yeah, I can take the root, but I'm just doing only the denominator without the root. If you want to go with the root, you can do that
It just
also.
comes 2 cos theta basically.
Yeah, so if you take the root, and if you want to separate the root of numerator here, so this will become 2 cos theta. My numerator will become 2 sin theta basically.
Yeah.
Correct. Now it's also important that you substitute for the powers also. I mean the limits also.
Okay.
So x is equal to 1. So 4 sine square theta
This is equal to
1.
sin square theta is 1/4. So sin theta is half.
So sine theta is equal to half. So theta is equal to how much?
Pi by 3. No, pi by 6, no? Yeah, pi by 6.
30 degrees. Pi by 6. Correct?
Hmm.
Then when your x is 0,
So 0 is sin square theta.
Huh.
So pi by 2.
yeah. 0, 0.
Sorry, it's 0, 0, 0.
Sin of 0, 0.
Yeah.
So then you substitute everything and that's integrated.
Okay.
So what will happen? One
Uh,
second. Huh? This thing sometimes stops working and it's stylus. Okay.
yeah, I only heard of A2 and A3 now.
Yeah. So 0 is equal to 4 sine square theta. So theta is equal to 0, 0.4. So that means now you substitute everything. So
My
we
limits
have
will basically become 0 to pi by 6.
0 to pi by 6.
Okay.
Root
2
of,
sin theta
so 2 sine theta,
over 2 cos theta.
2 cos theta,
8 sin theta cos theta d theta.
8, yeah, this is your 8 sine theta cos theta d theta.
How do you integrate that?
Now 2 and 2 cancels,
Yeah.
cos theta cancels.
So 8 sin square
8
theta.
integral of 0 to pi by 6,
Sin square theta d theta.
integrate sine square theta.
That should be here.
Now this is very important. Integral of sine square theta and cos square theta is very, very important.
Shouldn't that be given?
It's not given.
It's not given.
Now what you need to do is you square something that you cannot integrate on a trig function. How will you integrate square? So you apply the double angle formula. What's your cos 2 theta?
Root of 1 plus cos square theta divided by 2.
Cos 2 theta is equal to 1 minus 2 sine square theta.
Oh, that, okay, yeah.
So make sine square theta the subject. So you get this on the side.
1 minus
1
cos
minus
2 theta.
cos 2 theta upon 2.
Upon 2 and the root of it.
So 8. No, why root?
Okay, you're putting a sin square theta. Okay,
Ah.
putting that from one.
2 4 side. Correct? 4. Now what is the integral of this?
1 minus cos 2 theta is.
Theta. What is the integral of cos 2 theta?
That should be sin 2 theta divided by 2.
Pi by 6 is 0. So 4. Theta is pi by 6 minus sin pi by 3 minus 0 minus sin 0 upon 2. Correct? Which is 0 anyway.
Yeah.
So 4
So 2
pi by 6 minus sin pi by 3 sin 60 root 3 by 2.
divided by 2.
So root 3 by 4 it will become. Correct?
Yeah.
And this is all 0. So this is 4. We can take the LCM. 12.
Yeah.
6 2s are 12. 4 3s are 12. Correct. This cancels. So 2 pi minus 3 root 3 upon 3. So that's the answer.
I got stuck in the.
The increasing function f satisfied f0 is equal to 0, fa is equal to b, a is greater than 0 and b is greater than 0, means a and b are positive. By referencing to a sketch, show that the integral from 0 to f fx dx is equal to ab minus the integral from 0 to b f inverse x dx.
You lost me already.
But again, this is a classic sum, it's just too good. So this is x, this is y, correct? F0 0 and fa is b. Let's call this. But let's say this is an increasing function like this.
Okay.
It's an increasing function.
Okay.
This is my fx. Okay. Now what's going to happen is integral of what does the integral give you from 0 to a?
Whole area.
So this is my left hand side.
Yeah.
Left hand side is this area.
Now this makes so much sense. AB is the full area. And
AB is the area of the rectangle.
Correct. And f dash. Okay, so how would you plot the f inverse function?
To plot the f inverse function, what you do is your AB becomes BA.
Okay.
Your AB becomes BA. I've taken B as small and A as, so I've taken B as 1, 2, 3, 4 blocks. So 1, 2, 3, 4 blocks and 6 blocks this is.
Okay, good. Okay.
And you reflect in line y is equal to x basically. So this is my f inverse x. Correct?
Okay.
Now what's going to happen is, if I look at this will be this area.
Yeah.
The integral here will give you the other area.
Which area?
If I look at 0 to b, will give you this area.
Shouldn't it go always to the top?
No, 0 to b, no? Look at this. 0
Only
to
0
b.
to okay.
0 to b will give you this area.
And that part that's getting excluded would ideally not get excluded, right?
That a part getting excluded or not, I don't know. But one thing is there that will intersect at b comma b. So technically, this part should be intersecting here. Because remember that both the graphs, so b is here now. Means the function and its inverse, they'll intersect at.
So that part gets eliminated.
Yeah, that basically.
But so this is a little more.
Just a little more basically. Yeah, because that
but
graph.
Even that would get eliminated.
Yeah, that also will get eliminated.
Because it wouldn't. I mean, the proof wouldn't go.
Yeah. The proof by diagram is not perfect.
Okay.
Because the function and its inverse they meet at y is equal to x, means that b they'll intersect.
Okay.
So this also this my curve should pass through b comma b.
How come they wouldn't intersect at a comma a?
A comma a, it's an increasing function. Probably it will be any y is equal to x they'll intersect.
Okay. Any point on
any point y is equal to x.
Okay. Fine.
So now what's going to happen now?
This was basically just part 1.
No, by reference. Now, so what will you say? Yeah. So to shade this, and what will you write now?
So total area is A times B.
So basically, what's happening here is, but actually if they don't intersect at b comma b, but a function and its inverse have to intersect at y is equal to x.
Is that a rule?
Yeah.
How do you prove that?
It's a fact. It's a fact.
Okay.
So now how do you solve this then?
So you say the total area is A times B, and then the area
So
of the inverse curve is shaded in, say, color X.
X is the yellow area, correct?
Yeah.
And from 0 to B, F inverse X area is the pink area.
Okay, so this is wrong actually. Then.
Because then there's an overlap
Yeah, that's
region
what,
which is
what do you
coming.
do with overlap?
So you see, you show them not intersecting. No?
But how? But then so some other area will also be excluded, no? If you show them non-overlapping, like so, for example, if I draw it, so if I don't overlap my inverse and I draw it say like that, all of this region and some of that region will also get excluded, no? Like if I don't intersect the two, so my f inverse of x will go something like that, but then I have this region and this region, which will also get excluded.
One second, I'm trying to think. Upper function minus lower function gives you the area between the this. So actually the area between the region is upper function minus lower function. So function, it was something like this, and this is also, so what you can do is, okay. Now I sort of, okay. So can you do one thing? Forget whether they overlap or not. If I call this, if I call this area is A1, correct?
Which one, the yellow one?
The yellow one.
Okay.
And this area is B. So basically I'm looking at this. This is there. This is A. This is B, correct? So this is A1 plus B. So area A1 is from 0 to A fx dx, correct?
Correct.
Plus area of region B
is equal to AB.
Is equal to AB. Okay. Now, if you look at the inverse, this is like this. So this will become B and A. B and A swap.
Yeah.
Correct? This is my inverse. Oh, sorry, I made a mistake. This is wrong. The inverse is also with respect to the x-axis. Inverse area is also with respect to the x-axis.
Oh, you don't look. Okay, it's not with respect to the y-axis. So this area. Okay.
This is B2 then.
So if you were to graph them, if you were to draw them the same graph, what will it look like?
So it will be this area down. But it's better that we draw it separately. Correct?
Okay.
So this will be what? From 0 to B, f inverse x.
dy.
dx.
Oh, it's still with respect to
Huh.
Okay.
Huh.
Plus B2 is equal to AB. Now you equate the two. But that's not actually the thing that you want us to. Because you are eliminating AB meaning
No, one second. No? Okay. I got it. Okay. Now, okay, this we got. Yeah. Now what is B1?
B1 is AB minus A1.
What is B1? It will be integral from
0 to
B,
whatever the function dy.
Y dy, x dy.
Yeah. So the function is correct.
X dy.
Yeah.
Now my y is equal to fx. So your x will be f inverse of y.
Correct. Yeah.
So therefore 0 to A plus, what is it? 0 to B,
f inverse of y dy.
F inverse of y dy is equal to AB.
Yeah.
Correct?
F inverse of y dy is same as.
Now this is just a variable. This is a variable name.
Okay.
So you can replace it by anything.
Also, but it's fine if both your variables are called the same thing. So.
How? What difference does it make when you're doing definite integral? How does it make a difference?
So the proof says that both of them are f of x only. No?
But that's what I'm trying to tell you. If you replace this y with x, will it make a difference?
No,
because anyway you have to integrate and substitute.
Okay. Yeah.
Because whether we call this, actually there's a theorem in maths. I was trying to do that.
So only thing we have to basically come to is that y is equal to f of x. So f inverse of y is x. That's the tricky thing. Because
That's a
once you
tricky
get that,
thing, yeah.
you just have to substitute back to the same ratio which you given. Okay.
Hence, you to find the value of that. Acha, earlier part we got. What is the earlier part we got?
Like earlier sub part.
Earlier sub
The area.
part, yeah.
2 pi minus 3 root 3 by 3.
This one, no? No, not this. This one.
Yeah, this one is 2 pi minus 3 root 3 by 3.
But this is not this. Okay, this is not this. So you'll have to do it from scratch.
Okay.
So 0 to 2 arc sine x by 4 dx. Correct? Now first of all, let's understand what's my A, what's my B in this. So
This graph?
No, we're not referring to that. Now I'm just looking at the answer for this. I'm looking at the answer and I'm trying to use this theorem.
Okay.
So my fx is
Arc sin x by 4.
arc sin x by
4.
So f inverse of x
is sin x by
4. So now if you find the inverse of this function, let's see. So y is equal to sin inverse x by 4, correct? So x is equal to
4 sin 4 sin no, so 4 sin y is equal to x.
Right?
Yeah.
You replace x with y, y with x, right? Correct? Yeah, that basically we have done here. So to find the inverse, you replace x with y and y with x.
Yeah.
So you can think that way also then. Okay, so what will this be?
4 sin x is equal to y.
So y is equal to 4 sin x. So that's my inverse. Now to recognize your A and B. Correct?
Yeah.
So this is my A. What is my A? 2.
Yeah. B is 0.
Now your y, your B will be y. B is the corresponding y value of arc sine x by 4, correct? Arc sine 2 by 4. Arc sine half. What is arc sine half?
Sine inverse of half is
30 degrees. Pi by 6. So this is my A. This is my B. So if I use the theorem, what will it be? 2 into pi by 6, correct? AB minus integral from 0 to B of the inverse. Isn't it? This is A, B minus this is the inverse, correct?
So isn't B your limit?
B is not the limit. Arey Baba, B is the value corresponding to this now. When this is A, this is B. You put this value in the function. It's the Y value.
Okay. Because I'm getting confused. You know this theorem that we've highlighted. Over there our limits are also A and B, but then we also have A and B.
Arey, but B is the function, no? They have given you over here. FA is equal to B. B is the value of the function at A.
So this AB that we said is it's not related.
Well, AB is related to this A and B are multiplied.
Yeah. Okay.
So pi by 3 minus 4. What is the integral of sin x?
Minus cos x.
Correct? So this change the sign. TDS, huh?
Yeah.
So
4 times half.
this was the last sum of the paper.
Yeah.
They're very tedious they give. Cos pi by 6 is cos 30 equal to 3 by 2.
5 by 6 is 3.
Pi by 6 is 30. Pi is
180.
180.
5 by 6.
So that's your answer. Pi by 3 plus 2 root 3 minus 4.